In this experiment, we'll learn how basic electric circuits work, just like how a light turns on when you press a switch in your room. This will help us understand the concept of switching, so we can later relate it to electronic switching using a microcontroller like A.I.miracle. On the screen, you can see a simple circuit setup. An electric bulb connected by two red wires to a battery pack made by joining two batteries in series. This setup is designed to explain the concept of switching. When one terminal of the bulb is connected to the positive end of the battery and the other to the negative, the bulb lights up. That's because current flows from positive to negative through the bulb's filament, heating it up and converting electrical energy into light. But holding the wires together manually isn't practical. That's where a switch comes in. It makes controlling power easy. Just press the switch to turn the bulb on or off. Now imagine you want the bulb to blink. You'd have to press the switch on and off repeatedly, not ideal. Or maybe you want to make the bulb glow dimmer. That's where microcontrollers come in. Like bulbs, motors also need two wires to run. They're not polarity sensitive. If you swap the positive and negative connections, the motor still runs, just in the opposite direction. So in this experiment, we'll see how changing polarity changes the motor's direction. When controlling a motor using a microcontroller, we use two data pins. Let's call them A and B. If we set pin A high and pin B low, the motor spins in one direction. Swap them and the direction changes. Microcontrollers also let us control speed using something called analog output. Now let's build a three-wheeled car, mount the AI brick and connect it to the motors. We'll write a program to move the car forward for 3 seconds and control the motor speed using analog write. Let's get started. Let's open the Arduino IDE and create a new sketch. As we learned in the buzzer program, we first need to create variables to hold the pin numbers. In the A.I.miracle from the A.I.miracle kit, these pins are internally connected to the motor driver. For this program, we'll use the M3 and M4 motor ports. M3 is connected to D26 and D25. M4 is connected to D14 and D27. We'll create 4 variables to represent these pins. For M3, motor 1 P1 and motor 1 P2. For M4, motor 2 P1 and motor 2 P2. Next, in the setup function, we'll set all these motor pins as output using the pin mode function. Our task is to run the motors forward for 3 seconds at 50% speed. We'll use the analog write function to set the motor speed to 150, since the maximum value is 255. After 3 seconds, we'll stop the motors. We will use delay function to run motors for 3 seconds, and to stop them, we will make speed 0. Once the code is ready, connect your AI brick to the computer via USB, select the correct port in the Arduino IDE, and click the Upload button in the top left corner to transfer the program.